Question number 4, consider a binary mixture of volatile liquids. If chi of A is equal to 0.4, the vapor pressure of a solution is 580 torr. Then the mixture would be, given that P naught of A is 300 torr and P naught of B is 800 torr. Now, if that is a consideration, the binary mixture, what would be it? Options given are the chloroform and the acetone mixture, that is the option A. Option B, chlorobenzene and bromobenzene. Option C, benzene and toluene. Option D is N-hexane and N-heptane. Okay, so therefore, in this entire case, let's consider the entire scenario over here as PS, that is the vapor pressure of a solution, is equal to P naught of A into chi of A plus P naught of B into chi of B. Okay, let's take this into consideration. Now, PS, that is the calculated one, right? So is equal to, now if we go with this, P naught of A, that is the 300 as they have given us, into chi of A, what they have given us is 0.4. Plus, what we have is P naught of B, that is 800, into, now XB, now let's understand this particular format. So chi of A plus chi of B is going to be equal to 1. Chi of A value is 0.4 plus chi of B is going to give equal to 1. So therefore, what we are going to have is chi of B is equal to 1 minus of 0.4. Okay, so our answer over here for XB is going to be as, is equal to be as 0.6, right? So let me take directly over here as 0.6. So let's take this all out, right? And so now PS, that is the pressure of the solution, is equal to, we are going to have this over here as equal to 300 into 0.4, and that would be giving us an answer of 120 plus 800 into 0.6, that would give us the answer of around 480. Okay, so therefore PS is equal to, that is a partial pressure. Now this particular thing, partial pressure, that is partial vapor pressure of a solution. Okay, so that would be equal to around 600 torr. Okay, now what does this implement? It implements that the vapor pressure over here, that is a calculated one, is far more greater. Okay, it's far more greater than the actual vapor pressure or the vapor pressure given theoretically, right? So therefore, what happens is it is showing us more positive deviation. So therefore, it implements directly that this particular solution, that this particular liquid exhibits the positive deviations. Okay, so it is going to show us a positive deviation. Now, let's proceed further over here. We need to understand that if it is showing a positive deviation, then the interaction between the two components of a liquid, let's say liquid A and liquid B are the two different components. If something is showing us a positive deviation, that means the interaction, there is no good interactions between these two. Okay, so in short, they are going to have less interactions. There is less interaction between the two components which are added in order to get the mixture, as a result of which there is going to be more vapor pressure, then that has been exhibited by the Raoult's law. So if that is a condition, then first we will try to understand every single of these particular mixture one by one. So in our first case over here, that is, let's start with this. That is the mixture of N-hexane and N-heptane. Now here, what happens is, these are non-polar. Okay, so non-polar. So when it is a non-polar mixture, it shows absolute no deviation because of the no interactions. Okay, so no interactions. Same condition can be applied over here for the benzene and toluene mixture, as both of these are again the non-polars. So if it is non-polar, again, no deviations, no interactions. Options B over here. Now, in the B case, it is chlorobenzene and bromobenzene. Almost both of them are almost identical in aspects. So therefore, again, what happens is these are going to show us no deviations. What shows the deviation is, of course, it's going to be the option A, right? So the option A, wherein there is an acetone plus chloroform mixture. Chloroform, that is our CHCl3, and we have added an acetone to that, that is a CH3COCH3. So that this particular mixture is a mixture where it shows a positive deviation. So therefore, this is the answer, that is the option A. Thank you.